Hello, good afternoon or morning, whenever you're looking at this video, good people of geometry, and welcome to the very end of Geometry A. Congratulations on making it this far, and I thank you for all your work, and I hope you have a better understanding of kind of the basic ideas of geometry. Obviously, we could always go more in depth with any given idea, but we choose what could be a little challenging for some, but overall gets us the best benefit and value. So here we are. We're talking about parallel lines and proportional parts, and this fits underneath the big idea of similarity, and I'll show you why in a moment. Just because you kind of cut shapes into smaller versions of themselves. So let's kind of look at what we're dealing with here. And here's kind of what it says. Okay, so if you draw a line through a triangle, and it is parallel to one side, then it divides the sides into segments of proportional lengths. So now let's break down what does that mean. So if a line is parallel to one side of a triangle, okay, we're talking about going through the triangle. So if I talk about something simple such as this. So if I have a line going through this triangle such that it is parallel to that bottom line, okay, then what I have done is I've cut each side into different segments. Okay, so I'll label those A, B, C, and D. So what this says is that if I've done this, then I will say proportional lengths, okay? So I would say like A over C is equal to B over D. Okay, that's all it's saying. That's all it's saying. So if I label this line, we'll just call it L, okay? L for line, and then we'll call this length X. So if I just say L is parallel to X, then AC is congruent to B over D. A over C is congruent to B over D. Okay, and that's true no matter, I could rotate this shape, I could maneuver this shape any way I wanted to. But if I have parallel to one side and it intersects the other two sides, then it divides those into proportional lengths. Okay, that's kind of all it says. So let's kind of look. So here's what I've got. Okay, so I've got my triangle. PQR, ST is parallel to RQ, okay, which they've labeled for us. Nice. PT is 7.5. TQ is going to be 3. SR is going to be 2.5. Figure out PS. So we'll just put Y in there because we don't know what that is. So now, because these two are parallel, I can say, you know what? Y over 2.5 is going to be equal to 7.5 over 3. And then it just becomes some cross products. Okay, so 7.5 times 2.5, which if you can hear is I'm getting my calculator out to run that because I can't do that off the top of my head. It's going to be 18.75. So a little division. And my answer is going to be 6.25. So that should make sense. That answer should make sense. 2.5 is smaller than 3, so this number should be smaller than 7.5, but not by too much. Not by too much. Okay. So the flip side, all I'm doing is kind of flipping this around, and it's the same situation. Okay, so I've got my parallel line. Okay, so we'll call it, A, B, C, D. We'll call this length X. Call this line L. Okay, and it says if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. So this is just saying that same statement we said before, just in reverse order. Just in reverse order. So now I'm saying, you know what? If I can show A over C is equal to B over D, then I can say line L is congruent to line X. Okay, so it's just the converse, which goes way back to that logic unit. All I did was flip around the statement. So originally it was if this, then this. Now I'm flipping it around saying, if I can do this, then I can say this. Okay, all I did was flip-flop those. That's it. So now, DEF is the triangle I'm dealing with here. So let's look. HF is going to be 9. And DG is 1/3 the length of GF. Okay, EH is 3. And DG is 1/3 of this entire thing. Okay, so this would be, like 1/3. So this would be 1/3. This would be 2/3, if you wanted to say it that way. Okay, that's a decent way to say it. So now I got to compare the two. So now they're asking, is DE parallel to GH? That's the question they're asking. Okay, so now what I have to do is look at, is 1/3 over 2/3, is that equal to 3/9? Okay, so now the right-hand side, you can simplify 1/3, yes. Okay, that simplifies the 1/3. Right, left side, you might have to remember, think back to fraction rules. Okay, multiply both the top and bottom by 1. Okay, that cancels out, that cancels out. So that should be 1/2. Well, is that equal to 1/3? Then I would say no. Let's take a moment and look at this just to make sure we didn't make any mistakes. So let's see. DG is 1/3. That means GF. Oh wait. I'm sorry. Well, I made a mistake there. I'm sorry. I'm truly sorry about that. 1/3 the length of GF. See, this is why it's a good idea. 1/3 the length of GF. Okay, so this is like 1 to 3. That is okay. So I made a mistake over here. I apologize for that. Okay, that's why it's good to reread the problem sometimes. So that's a good lesson. So this becomes 1/3. Obviously, that's 1/3. So yes, that will work. Because 1/3 is of GF, of just this length right here. Okay, if I said 1/3 of DF, this wouldn't work. This would not work. Okay, so this is just like saying 1/3. This would not work. Okay, so lucky they said GF. So GF works right there. Okay, I apologize for the confusion. But that's a good lesson in rereading the problem. Okay. So a mid-segment, and this is a word, this is a vocab word that you kind of need to be aware of. Its endpoints are the midpoints of the triangle, of each side of the triangle. Okay, so as we call this, we'll call this M, we'll call this D, and we will call this S. Okay, these are all midpoints of the sides. Okay, so every triangle has got 3 mid-segments. So MD is a mid-segment. MS would be a mid-segment. And DS would be a mid-segment. Okay, these are all mid-segments. And the reason for that is because these all cut in half. That's why. Okay, that's what it's saying. Mid-segment of a triangle is the connection of midpoints is essentially what it is. It's connecting all the midpoints. Okay, so let's look. So a mid-segment theorem. So if I have a mid-segment of a triangle, it's parallel to one side, and its length is 1/2 of the length of that side. Okay, so what does that mean? So we're going to argue, okay, so I've got a mid-segment here, and we're going to say, okay, that's a mid-segment there as well. So we're going to connect these two. Okay, so this is quite obviously parallel to that. Okay, this is quite obviously parallel to the bottom. And this theorem simply says, all it says is that if I have this length x, this is just going to be half of x. Okay, that's all it's going to be. Half of x, or x divided by 2, or whatever you want to suggest there. And that's true for every mid-segment. So I know on the previous one, I had like 3 mid-segments and all that. So that's true for every mid-segment. Every mid-segment. Mid-segment is going to be half of the parallel side. Okay, half of that other side that is parallel to. Okay? Okay, so that's not a difficult relationship to remember, I would think. Okay, so let's take a look here. So we have this triangle. We have some segments. Okay, they're telling us they are mid-segments. XY, mid-segment. XZ is a mid-segment. They tell us that's 124. I don't know if that's going to be helpful or not. So they need to figure out XZ. Well, XZ is right here. Okay, that's XZ. It tells XZ is a mid-segment, and it's a mid-segment to here. Okay, so that would be, if this is 13, then that's just going to be half, and that's going to be 6.5. Okay, pretty straightforward. Pretty straightforward. So now, ST is the one I'm looking for. Okay, so now that's going to match up to that mid-segment, to XY. Okay, so the mid-segment there is XY. Okay, so they say XY is 7. So I just need to double that. That's going to be 14. So that's going to be that length. That's going to be that length. 14. Okay, last problem here. RYX. So RYX, this angle right here, what's that equal to? Well, I would consider, well, the answer is going to be 124 degrees, and let me show you why. So let me get rid of some of this stuff, and let me draw just kind of the important things here. So you have RYX, okay, and then this segment goes over to Z, and that's 124, and that's just mimicking right here. Okay, that's all that's mimicking. So now, if I just kind of extend this out, these two are parallel. These two are something called alternate interior angles, which is a throwback to Unit 2. Throwback to Unit 2. That's kind of what you're looking for there. So that's why it's 124. Okay, so once again, all those rules come back off of that, off of Unit 2. Okay. So now let's take a look. Okay, this looks a little slightly more complicated. So IJ is a midsegment of FJH. Okay, it's a midsegment. So you need to figure out how kind of this works. Figure out X and Y. So IJ is a midsegment. So let's figure out X first. So X is here and here. So 2X plus 5 equals 5X minus 7. And I know that because IJ is a midsegment. So a midsegment cuts these two in half. Okay, so I'm using the fact that FJ is congruent to JH. Okay, but because of, definition of a midsegment. So a little bit of algebra later. Dividing by 3, so X will equal 4. Okay, that was not too bad. That was not too bad. For Y, and here's the number one mistake kids will make. They will automatically assume, hey, 5Y plus 1 equals 8Y plus 6. Okay, that is wrong. Okay, because remember, IJ is a midsegment. IJ is a midsegment. That means it's going to be half of this. Okay, it's going to be half of this. So that means it's not 5y plus 1. It's actually 2 times 5y plus 1. Okay, now that's correct. Now that's correct. I'm doubling my mid-segment, and that's equal to my parallel side. Okay, so this is really 10y plus 2 equals 8y plus 6. Okay, so some algebra later, 2y equals 4, so y equals 2. There's my answer. There's my answer. Okay. Okay. So now let's take a look down here. F is 50 degrees. H is 30 degrees. Find JIF. So find this angle right here. So find this angle right here. Okay, so remember these are parallel. So if this is 30, this is 30. So 50 and 30 make 80. So if I know a triangle has to add up to 180, and I know those two are 80, that makes I 100 degrees. There's my answer. There's my answer. Okay, so now last problem here. Let's take a quick look. Okay, so couple things. Let's start with this. B would be easy. Okay, this is 8. They want B, so B is just going to be 8 times 2. B will be 16. Okay. Oh, wait. Back up. We don't know that this is a mid-segment. We don't know this is a mid-segment. In fact, we know it's not because that's 4 and that's 6. That's 4 and that's 6. Okay, so now we have to get a little more clever here. So we have 7, and this whole thing is A. We have 4, and this whole side would be 10. So that's the ratio I'm going to use. I'm going to use part over whole, and I'm going to use that as to kind of figure out my answers. So I'm going to go 4 over 10 equals 7 over A. And then I'm going to go 4 over 10 equals 8 over B. And again, I'm doing this because we do not know that this is a mid-segment. Okay, well, in fact, we know it's not a mid-segment. We know that it's not a mid-segment. So I'm going to go part over whole because I know this one. Okay, I know this one. All right, so let's see. That would be 4A equals 70, just using cross products. So A would be equal to 70 divided by 4, which is going to be 17.5. Then I'm going to follow that same pattern for here. And the reason I didn't go 4 over 6 is because this would be part over part. And I want part over whole. Okay, that's the one I want because that's what the other two sides use. Okay, so I have this 7 over this whole thing A, and then 8 over B. Okay, so 4B equals 80. B would then equal 20. Okay, there's my answers. There's my answers. So now what do you have left? Okay, so you need to do the 5-4 homework and quizzes. Unit 5 test. And then it's all final stuff. Final reviews. And the final. And that's all you have left for all of Geometry A. Okay, well, good luck. I look forward to answering your questions.